Hello again. We're going to talk about now 6.3 volumes by cylindrical shells. Remember when in 6.2 we talked about volumes using discs, or washers. We use the formula, the volume equals pi, the integral from a to b, radius squared dx. Of course, it could be dy. Of course, if it's a washer, this will be a difference. Outer minus inner radius. Now, let's see what this is all about, what it's a cylindrical shell, and how do we think about it? Because sometimes we're not going to be able to use this method. And I'll show examples, of course. Bear with me and say that this is a cylinder, assuming that it's completely solid. There is no opening, there is no, it's not hollow, right? So assuming that this is a cylinder, we have another way of determining its volume. And I like to call this method basically decomposing it in small pieces. Okay, so this is a cylinder. It's a full solid cylinder, no emptiness. And I want to determine the volume in this way. I will peel one shell. Then I will peel the next one. And you got the idea. I will peel the next one. Of course, in my example, these are identical in size, volume, everything. Well, of course they will not be, because the inner shell, after I peel the outermost one, the inner one will be smaller. Not by much, but definitely smaller. So when I peel the cylinder, which initially was this, when I open it up, like peeling an onion, if you want, taking its shells one by one, apart by one. So look what the volume of this first shell is, like all of them, till the middle one, right? Till the last one. What is the volume here? It's area of the base times the thickness. One more time. Area of the base times the thickness. But how do I determine this? Base times height times thickness. Of course, the thickness is always dx or dy. But how do I determine this length? Because I know this is the height of the cylinder, no worries there. But how do I determine this? Oh, it's nothing else but the circumference of the circle. So this is 2 pi r, this is the height, and this is the width. So if we want to represent one shell here, let's say, it will be something like this. So this is what I'm showing with this piece of paper. So this is this length, which will be 2 pi r. And this is basically the height of the cylinder. Height. So the formula this time will be, for cylindrical shells, 2 pi, the integral, of course, where the area is, from a to b, radius times height times dx. Of course, it could be dy, depending on how we integrate, if we integrate with respect to x or with respect to y. So this is what the cylindrical shells. And this is the formula for disc washers. Okay? So when I apply the disc washer method, I always have pi r squared, or the difference if it's a washer. And whenever I use cylindrical shells, the formula is 2 pi, the integral, of course, radius, height, dx or dy. So now let's illustrate with examples. And I would like to start with 53 on page, I think page for 53 is 466, yes. And then we're going to look at 54 as well on 466, and then we'll choose other examples. Okay, for 53 first. We are given y equals negative x squared plus 6x minus 8. We are given y equals 0. And they're telling us to rotate about the y-axis. Okay. Like before, first we have to draw. We have to picture the rotation and figure it out if we integrate with respect to x or with respect to y. Now, before we continue, I want to mention again here, for the disks and washers, if we rotate with respect to a horizontal axis, we go from left to right, and that's dx. When we rotate with respect to a vertical axis, we go from low to high, and we integrate with respect to y. It's exactly opposite for this. Exactly opposite, meaning if we rotate with respect to a horizontal axis, we will be integrating with respect to y, not x. When we rotate with respect to a vertical axis, not y, but x. It's the exactly opposite, okay? And let's illustrate with these examples now. Okay, so I know that this is a parabola. The first thing I do, I will factor out -1. I have x squared minus 6x plus 8. Of course, I have to notice at this point that this is x minus 2 and x minus 4. And I know in order to graph a parabola, I need to identify whether it has a maximum or a minimum, x and y intercepts. Okay, so I start with when y is 0, of course, that's why I factor it right away. X equals 2, x equals 4. So I found the x-intercepts, 2, 0, 4, 0. Now, when x is 0, 0, 0, negative 8. So y equals negative 8. So 0, negative 8. Also, if the x-intercepts are 2 and 4, I know that the axis of symmetry must be when x is 3. There is no discussion there. So when I plug in 3, I get -9 plus 18 and minus 8. And this is -1. +1, sorry. Good. So then the vertex of the parabola will be 3, 1. So we determine x and y intercepts, we determine the vertex, we have the axis of symmetry, we are ready to graph this parabola. Y equals 0 is a piece of cake. So let's do that. I'm on page 2. Good. So let's graph. One, 2, 3, 4, 2 and 4, 3 and 1, and -8. Okay, that's not important very much, but when we graph a parabola, always graph the axis of symmetry to make sure that the graph is in shape. So this is always write what you're graphing. Label. So this is y equals -x squared plus 6x minus 8. Y equals 0 is obviously this. So this is the area in question. We are asked to rotate it with respect to the y-axis. I'm going to picture on the other side. 1, 2, 3, 4. So something like this. So that's the mirror image. So then when we rotate, we create this solid. As I mentioned a few minutes ago, when we rotate with respect to a vertical axis, it's the opposite of disks and washers. We will integrate with respect to x. So I have to prepare, I didn't mean to write that, 2 pi, the integral from, of course, 2 to 4. And I have to have a radius, I have to have a height, and I have to have dx. Good. So let me take care of this. 1 second. Sorry about that. Good. Good. So then, remember we are integrating with respect to x. Like before, nothing changes here. I say this, respect to x, through the area for a particular x value. I picture an independent or particular shell or piece. For that piece, I need to determine the radius, and I need to determine the height of the piece based on where we are with respect to the axis that we are rotating. So this is the radius for the piece. And for any piece, it doesn't matter, between 2 and 4, where the area is, this is x. No problem. So all I have to write is just x. Now I need to determine the height. The height of the piece that we have here. So this is the radius, nothing else. Okay, well, what is the height? It's the y value. What is the y value? Well, the y value is negative x squared plus 6x minus 8. I'm going to write it from scratch. So then the volume equals 2 pi, the integral from 2 to 4, x, negative x squared plus 6x minus 8 dx, where the radius from the axis where we are rotating till any piece that you want to choose. You can choose this here, you can choose it in the middle, doesn't matter where you choose it. It's still x, the radius is x, and the height of the little piece is nothing else but the y value for this x. All we have to do next is just determine the integral, and it's done. The integral from 2 to 4, negative x to the third plus 6x squared minus 8x and dx. So this is 2 pi. The integral from 2 to 4. I don't need to write it again. Sorry about that. So 2 pi, negative x to the fourth over 4 plus 6x to the third over 3 minus 8x squared over 2. So, of course, from 2 to 4. So this is 2 pi. I plug in 4, negative 4 to the fourth over 4 plus 2 times 4 to the third minus 4 to the third. Careful now. Plus 2 to the fourth is 16 over 4, which is 4, but minus 8 times 2, 16, but plus 4 times 4, 16. Okay, so it happens that these two will go away. I don't want to confuse anyone. Let me remove this piece from here. It's useless. Got carried away. I was writing it again for no reason. Good. Okay, so let's see what we get here. Okay, so 2 pi, when I simplify, I get 4 to the third, and 4 to the third is negative 64. This is 4 to the third times 2, which is positive 128. And this is, again, negative 64, and this is plus 4. All these will go away, negative 64 with negative 64, negative 128, and this is 8 pi. And this is the volume that we obtain by rotating this area around the y-axis. Now let's look at problem 54. So that was 53. Let's look at 54 and see what happens. 54. Of course, on the same page, what was the page? 466. We're asked to repeat the process, but this time we are going to rotate with respect to the x-axis. So I'm going to copy the same problem. Negative x squared plus 6x minus 8, of course y equals 0, but this time about x-axis, the x-axis. I'm going to copy the graph because we already have it. So let me copy the graph. I'm just going to copy what I need right now because we went through all this process already. That's all I need. So this is y equals 0, and of course this is the function y equals negative x squared plus 6x minus 8. And this time we are rotating it with respect to the x-axis, they say. Okay, fine. Okay. Let's suppose that we're thinking of applying the same procedure as before, which is 2 pi cylindrical shells, 2 pi the integral now. Remember, we are rotating with respect to a horizontal axis. For the discs or washers, we go from left to right. But in this case, for a cylindrical shells, we integrate with respect to y. Okay, so obviously it's from 0 to 1 for y, from radius, height, dy. Let's see what happens. So when we integrate with respect to y, we will say for a particular y value. I picture the shell, the little piece. I picture the radius because I'm rotating now with respect to this axis. No problem. But see, in determining the height of the piece, I have to solve so the height somehow cannot, I have to determine it in terms of y, but I have no way of doing that. So there is no way I can use cylindrical shells for this situation. But I do have the method of discs. I'm not going to write there. I want to copy it again. So here it is. So between 2 and 4, and with the height at 1, the vertex at 1, here it is. So we are rotating it with respect to the x-axis. And when we use discs and washers, when we rotate with respect to a horizontal axis, we go from left to right. So this time it's between 2 and 4. And remember the formula, pi 2 to 4 radius squared and dx. Okay, for a particular x value. Okay, I only need the radius. But what is the radius? For this, so the radius is x,